5.3 is all about factoring. Now, what counting was to kindergarten is what solving was to Algebra 1. Is what factoring is to Algebra 2. Y'all, you need to be ninjas at factoring. By the end of this semester, we will have 7 ways to solve. In fact, it will actually be 9. But the ones that we're going to use the rest of the year, there are going to be 7 ways to factor. Now, we're going to learn the first 4 today. And the first 3 you've probably seen at one point or another. The last one you may or may not have seen. But roll up your sleeves. Let's take some notes. The first one is called the greatest common factor. Greatest common factor, or I will affectionately refer to it as GCF. GCF. Now, GCF is essentially undistributing. What are you talking about, Smith? Let's do an example. And let's put in, all right, get ready to write. 4x to the 5th, y to the 3rd, z to the 9th, plus 32, x to the 3rd, z to the 15th, minus 4, x squared, z, just like that. Go ahead and pause if you need it and copy that down. But we're going to GCF. Now, there are 3 terms that are going on here, right? 1, 2, 3. And the first thing you're going to look at is the numbers. 4, 32, and 4. What is the greatest common factor that all 3 of those numbers have in common? In this case, they all happen to have 4 in common. Now, look at the x's. All 3 of these terms have x's. They each have at least 2 x's. So we're going to write the greatest common multiple, x squared. They all have at least 2 of them. Do they all have y's? You got y, no y, no y. So is y a common factor? No, so we can't pull any of them out. But z's, they all do indeed have z's. They all have at least, this one's got 9 of them, this one's got 15 of them, this one has 1 z. So 4x squared z, that is the greatest common factor. But like I said, we are going to undistribute. So parentheses, then you would take each term and you're going to divide it by 4x squared z. So 4 divided by 4 is 1. There were 5 x's. We took 2 of them out. So there's 3 left. We didn't do anything with those y's, so those y's are still there. There were 9 z's. We took 1. So now it's z to the 8th power. Plus, we go on to the next term. 32 divided by 4 is 8. There were 3 x's. We took 2 of them, so there's 1 left. There were 15 z's. We only took 1, so now it's z to the 14th power. Minus 4 divided by 4 is 1. I'm going to put that 1 here this time. X squared divided by x squared. Well, there were 2. We took 2, so there's none of them left. There was a z. We took it. There's none of them left. Now, be careful with this negative 1. You're going to have this negative 1. This is like a placeholder. If we were to distribute, yikes. If we were to distribute this back, we should come back with the original problem here. So 4x squared times z times this mess will give us this. 4x squared times z times 8xz to the 14th gives us the second term. You need this 1. Even though we took everything, remember we're actually dividing. 4x squared z divided by 4x squared z is 1. Because if we were to distribute it back, 4 times this mess, we need that 1 to get this back. Greatest common factor. The next one. The next one is called difference of squares. Difference of squares. Now, difference of squares is always going to be a common pattern. It's going to be a squared minus b squared. It's going to be 2 perfect squares that are being subtracted. Hence the name, difference of squares. Right? And that's going to factor 2. two sets of parentheses. It's going to factor to a plus b times a minus b. All right, so we're going to do a couple of examples here. The first example we're going to do is x squared minus 49. X squared is a perfect square. 49 is a perfect square. So what might be helpful, if a squared is x squared, then a is x. Right? If b squared is 49, then what is b? B is 7. You with me on that? Square root of 49 is 7. 7 squared is 49. So once you identify what a and b are, then you can factor this. A is x, so it's going to be x plus 7 times x minus 7. All right, let's do another example. Now, so far, we've talked about two ways to factor. This one involves both of them. X squared minus 50. Or excuse me, 72x squared minus 50. From now on, whenever you factor, the first thing you're always going to look for is a GCF. You're going to look for a greatest common factor. And this one kind of reminds you, is 72 a perfect square? What times itself is 72? Nothing pretty. Is 50 a perfect square? Nope. Neither of these are perfect squares. So the first thing you're going to look for is a GCF. What can come out of 72 and 50? What do they both got in common? They each have a 2 in common. So 2 times the quantity of 36x squared minus 25. We did the GCF first. Now look what's inside here. 36x squared. Is 36 a perfect square? Sure. X squared is also a perfect square. 25 is a perfect square. So 36x squared, if a squared is 36x squared, then what is a? A is 6x. Right? Think about it. A squared means what times itself? 6x times 6x is 36x squared. If b squared is 25, then what is b? B is 5. So, factor this, our final answer. The 2's got to come along with two sets of parentheses. And it's going to be 6x plus 5 and 6x minus 5. Those are, this is the factored form. Box my answers here. All right, let's do one more example of difference of squares. Let's go with 64m squared plus 9. So, first thing, always look for a GCF. 64 and 9. Did they got anything in common? No. So, 64 is a perfect square. 9 is a perfect square. So they're both perfect squares, right? The only thing is this a difference of squares? See how these were both minus. This one is plus. There's no such thing as the sum of squares. Thus, this does not factor. What do you call a number that doesn't factor? A number like 7 or 5 or 11. What kind of numbers are those? Yeah, they're odd, but they're also prime. This is prime. If it doesn't factor, this is what's called a prime example. All right, there's two ways, two methods. Number 3. Number 3 is the one you're probably more familiar with. You did a lot of it last year in geometry. I have a bunch of names for this. Regular style. I call it old school. I call it factoring. X squared plus bx plus c. This is the main of it. What we're essentially doing here is we are unfoiling. That's what's happening here. We are unfoiling. So, as I mentioned, the pattern of this is always going to be x squared plus bx plus c. the trick to this, if you have to find two numbers that multiply to C but add up to B. Two numbers that multiply to C but add up to B. All right, so let's do an example here. We'll do a couple of examples here. First example is going to be x squared plus 8x plus 15. Oops, 15. So remember, the trick is what multiplies to 15 but adds up to 8. What I recommend doing is problems like this. List out everything that multiplies to 15. Now 15, there's not a whole bunch. You got 1 and 15. 2 doesn't go in. There's 3 and 5. Yes. That's it, right? Because 4 doesn't go in it, and then you're back to 5. 5 times 3, and you're back here. So these are the two things that multiply to 15. But which one of these, when you add them up, add up to 8? Well, 3 and 5. All right, so our final answer here, make two sets of parentheses that are being multiplied. X plus 3, and you got x plus 5. How could you check your answer? Well, FOIL it out. You should come back to x squared plus 8x plus 15. Let's do another example. How about, get to hear announcements. How about x squared minus 11x plus 24? Now, when it's 24, there's all sorts of stuff that multiplies to 24. Here's what I mean by listing out the products of 24. Go in order. Be organized and take your time. You got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Does 5 go in there? No. Does 6 go in there? Yeah, 6 times 4. But check it out. We all already have that. So these are all the things that multiply to 24. However, they have to add up to negative 11. Now, none of these add up to negative 11. That's a problem. But because it's positive, there is a chance that both of these could be negative, right? Negative times negative is positive. So these are all negative. Now, which one of these adds up to negative 11? Negative 3 and negative 8. So this factors 2. X minus 3 times x minus 8. All right, so those are the three that you've probably seen at one point or another in Algebra 1 or last year in geometry. I know you did a lot of factoring like this. But that brings us to the fourth one. Now, this fourth one is my favorite. This is called factoring ax squared plus bx plus c. Smith, we just got done doing that. Well, here's the thing. This is ax squared. There's a coefficient in front of x squared where up here there was not. It was just x squared plus bx plus c. The coefficient here is 1. This is where it's anything other than 1. So let's do a first example here. Our first example here is 2x squared minus x minus 15. Now you might want to watch this example a couple of times. Let's do an example here. First thing that you're going to do is you're going to multiply the ends together. You take the ends and multiply the ends together. So 2x squared times, now this is negative 15 is negative 30 x squared. Step 2. You got to determine what multiplies to negative 30 but adds up to negative 1. So, what multiplies to negative 30 but adds up to negative 1? And you're going to split that off. You're going to get negative 6x plus 5x. Y'all with me? That multiplies to negative 30 but adds up to negative 1. So that's step 2. Step 3. Bring the ends down. Or bring the wings down. So this is 2x squared minus 6x plus 5x minus 15. Alright, so then you're going to make two groups of two. Two groups of two. So I'm going to put parentheses around the first two terms. Now in this case it doesn't matter, but make sure this is a plus. So if this is minus, you do plus and negative. Make sure that the plus is between them. Two groups of two terms. Then you're going to GCF each step. So 2x squared minus 6x. What can come out of here? Well, a 2 can come out, and they each got x's, each have at least one x, so an x comes out. You got 2x times the quantity of x minus 3. Then looking at this one, 5x minus 15, what can come out? A 5 can come out, and what got left behind? X minus 3. The next step is we're going to GCF again. Now, if you look at this, you got 2x times this thing, x minus 3, plus 5 times this thing, x minus 3. So the common factor here is x minus 3. And when you take that off, you're left with the blue answer here, 2x plus 5. Then once you're done, draw in the rest of your bats. Make sure you draw the column.